So let us continue with similar triangles, theoretical as well as numerical problems. So let us begin, students. If ABCD is a quadrilateral in which ABCD is a quadrilateral in which AD is equal to BC, AD is equal to BC. This is the condition given, and AD is equal to BC. PQRS are the midpoints of PQRS are the midpoints of AB and AC. Next, DC and BD. Show that PQRS is a rhombus. So PQRS is a rhombus. Since P and Q are the midpoints, P is a midpoint, Q is a midpoint of triangle ACB. Since P and Q are the midpoints of triangle ACB, of triangle ACB, what can you say? Therefore, PQ is parallel to PC. Once again, ABC, you consider this triangle. Since P is the midpoint, Q is the midpoint, PQ is equal to half of BC and PQ is parallel to BC. PQ is parallel to BC and PQ is equal to half of BC. Right? Next, consider this triangle. Consider triangle DBC. Consider triangle DBC. DBC. In triangle S and R are the midpoints. So therefore SR is parallel to BC. Therefore SR is parallel to BC. Also SR is equal to what? SR is equal to half of PC. Right? I am taking this triangle, this one, DBC, SR, this one, SR is parallel to BC and also SR is equal to half of BC, right? Therefore, you see here PQ is parallel to BC and SR is parallel to BC. Therefore, mark this as 1, mark this as 2. From 1 and 2, what you can say? From 1 and 2, PQ is parallel to BC and also SR is parallel to BC. That means PQ is parallel to SR. PQ is parallel to SR. This is parallel to this one. Next, are you getting? And again, PQ is equal to half of BC given and SR is equal to half of BC given. PQ is equal to SR is equal to half of BC. So therefore PQ is equal to SR, right? PQ is equal to SR. Now let it be like this. PQ is equal to SR we have proved and also PQ is parallel to SR. Now we have to prove that PQRS is a rhombus. Now Q and R are the midpoints. Consider triangle DAC. In DAC, QR is parallel to, again I am not writing, Q and R are the midpoint. Therefore, in triangle DAC, QR is parallel to AD. QR is equal to half of AD. Right? QR is equal to half of AD. QR is equal to half of, here AD and BC are given, no? AD and BC here. AD is equal to BC given. So QR is equal to half of, in place of AD, you can write BC. In place of AD, you can write BC. Therefore, from one and from this and this, what you can write? QR is half of BC here. QR is equal to half of AD I have written, but AD is nothing but BC, no? QR half of BC. Half of BC is nothing but, mark this as, therefore from Roman numeral 1 and Roman numeral 2, therefore from 1 and 2, QR is equal to, PQ is equal to, PQ is equal to SR, but SR is equal to half of BC is nothing but QR is equal to half of BC. PQ is equal to SR, PQ is equal to, PQ is equal to SR, but SR is nothing but QR. Now, until it is clear, any doubts? So we have proved that this is parallel to this. Similarly, you can write PQ is parallel to SR. From 1 and 2, you can write like this. Similarly, we can prove, you can write here. Similarly, we can prove this PQ is parallel to SR means, similarly, we can prove that RQ is parallel to SP. Similarly, you can write, no problem. PQ is parallel to SR. Similarly, we can prove that RQ is parallel to SP. Now we are proving that all sides are equal. Almost all sides, PQ is equal to SR is equal to QR is equal to half of. Now only one side is left over, S. SR is there, QP. QR is also over, and SP is there. SP, that is the one side left over. I am erasing, since once again P and Q are the midpoints. PQ is equal to half of BC, right? Next, again SR is equal to half of BC, but half of, I equated both, therefore these opposite sides are becoming equal. And again we have proved that, again I did like this, PQ is equal to SR, this is over. In triangle DAC, and again SP RQ, here RQ is equal to half of AD, something like that I did, and again half of DC, that is nothing but this one. Only one thing is left over, that is this one, SP. Now consider triangle SP, S and P are the midpoint, so SP is equal to half of AD. This one raising. S and P are the midpoint, so SP is equal to half of AD. SP is equal to half of AD. AD is nothing but BC, no? So SP is equal to half of BC. Half of BC is nothing but this one. Therefore, PQ is equal to SR is equal to QR is equal to SP, that is equal to half of BC. Now all sides are equal and also opposite sides are parallel, therefore it is a parallelogram. Very lengthy problem, but it's quite easy. Next problem. Here you need to apply only two theorems. Only one theorem I applied here. The line segment joining the midpoints of two sides of triangle is parallel to the third side and also half of the third side. But AC is equal to BC is equal to AD given. Therefore, I replaced and then hence the problem. In the following figure, DEFG is a square and angle BAC 90. In the following figure, DEFG is a square and also angle B is equal to angle BAC 90. Prove that DE square is equal to BD into EC. So how to do this one? Very simple. We have to prove this one. Therefore, DEFG is a square. So we have to prove this one. BDE square is equal to BD into EC. Consider this triangle. So here, did they give any condition here? In the following figure, DEFG is a square, angle PAC 90. So if this is 90, in a square each angle is 90 now. Therefore, this is also 90 degrees. Right? Next, how to prove that this angle is equal to this angle? Any idea? This 90, one angle is already 99 for this big triangle, and for this small triangle, one angle is coinciding. Next, okay, how will you do this one? Here, what kind of angles are they? Here, x and x. What type of angles are they? Since GF is parallel to DE, since GF is parallel to DE, GF is parallel to DE, GF is also parallel to BC, BD. GF is also parallel to BD. Therefore, angle AGF is equal to angle GBD. Both are equal to x. While both are equal to x, corresponding angles. One angle is exterior, one angle is interior. They are lying on same side of triangle. Therefore, triangle AGF is similar to triangle AGF. Letter A and A should coincide. Consider triangle this. Consider triangle AGF and GBD. AGF and GBD. So, angle A is 90, angle A is equal to 90 degrees, that is equal to angle BDG. This is 1. Next, angle AGF is equal to angle GBD. Both are x, something like that. AGF, GBD. Therefore, triangle AGF. Letters should coincide. A letter should coincide with D. G letter should coincide with B. Next, and also DB is over one letter is G. Therefore, similarly, right? Did you understand this? Only one thing I have read. GF is parallel to BD. It is a square. Since it is a square, since GF is parallel to AB, because GFED is a square. GFED is a square. That is why we are writing GF is parallel to DE. Otherwise, we would have not written this statement. Since GF is parallel to AB, GF is also parallel to BD. Therefore, and hence I followed this one. Why these two are similar? Because angle property. If two angles are equal, then the triangles are similar. Therefore, similarly, we can prove that. What? Triangle AGF is similar to triangle. This 90 degrees means this letter should coincide with A, this one should coincide with E, and F should coincide with C, and what is there? EFC. F letter should coincide with C. F letter should coincide with C, and A letter is coinciding with E, and what is F for? E. Therefore, these two triangles, see here, mark this as from 1 and 2. From 1 and 2, AGF is similar to DGB, AGF is similar to EFG. Therefore, from 1 and 2, DBG is similar to triangle EFC. Right? So, from 1 and 2, I got like this. Apply ratio property. BD by EF is equal to first and last. DG by EC is equal to next last BG by FC. So here what you have to do, D square, keep it in mind, D square, where we are getting D square, okay, leave it, and BD is equal to BD into AC. Just see here, BD into AC is there, no, just cross multiply, BD into EC is equal to DG into EF, DG into EF, BD into EC is equal to DG. Look at this diagram, DG. DG is nothing but what we are from is asking D square. DG is nothing but D is equal to EF. EF is also nothing but D. Since all sides are equal. In a square all sides are equal, no? That's why in place of DG, I am writing DE. In place of DE, in place of EF, I am writing DE. Therefore, DE square is equal to BD into EC. Hence the theorem. So, thank you students. Have a nice day. We'll meet you in the next class. Bye.